Welcome back. There are 4 units of CSE 505. 505 is kind of a foundational overview for the program. And interestingly, Unit 1 is kind of a foundational overview of the class. Okay? We're going to talk about, ultimately, 9 grand ideas of information technology. These are the things that we believe, if you really understand these things, you will understand what information technology is all about. See, there's a couple different ways that we could approach the subject. We could either look at a number of different specifics and try to develop expertise there, or we could see if there's some kind of common ground, if there are some fundamental concepts and ideas that really permeate and support everything else in our discipline. So our approach is to take a look at those things, the so-called grand ideas of information technology. But before we jump into that, let me just share some other important ideas or concepts with you. Every once in a while, I'll start numbering things at 0, just to remind you that IT folks, we do start counting at 0. 0 isn't nothing, right? I mean, that's the beginning point if we're going to count 0, 1, etc. Right? You know, this is probably a good place to begin. We're in an IT program. Many of you, I know, are already working or have worked in the IT field. So what is information technology? Well, let me give you my concise, succinct definition of information technology. Now, don't worry. You'll have an opportunity to expand this. I don't want you just to take my definition and parrot it, but I mean, if somebody asked you, if your grandmother asked you, what is information? You work in IT. What's information technology? I mean, we should have a concise, succinct definition that we could share that hopefully would make a little bit of sense. Okay? So, what is IT? I'd like to spend the first hour defining what information technology means. Ooh, can I help pass out the materials? It's not a good idea to mix enthusiasm with stupidity, ASOC. Oh, sorry. If you don't know, this is Dilbert. Dilbert's a fairly popular comic strip, especially among information technologists. Dilbert, the hero, that's the person on the far right with the glasses there, is an IT professional. He is a software/hardware engineer. And many IT and computer scientists and other kinds of engineers and technologists really resonate with it because he shows the foibles of trying to manage technology and produce technology on the job, etc. So I'm going to share this. Even if you don't laugh, I'm going to share these with you, okay? Because I find them funny, and I need to be able to laugh, okay? That's a lot of stuff. Okay, you'll learn to love all the characters. And if you can't wait till next week, you can go to Dilbert.com. And not only is today's on and last week's, but everything since the beginning of Dilbert time, which is, I don't know, 1990 something or the other. Okay? Before I give you my definition, I'm not asking for a definition yet. But when you hear the word IT, let's just free associate, can we? Will you just throw out some words or terms or... So somebody says IT, what do you think? Data. Good. Just throw stuff out. Just if you have something, just say it. I'm sorry? Application. Software. Problems. Networking. Database. Solutions. Data, application, software, problems, networking, database, solutions. These are all good. Others, other thoughts. Instructions. Analysis. Productivity. I'd like to tell you that it's so sloppy because it's so late in the day, but it wouldn't matter. Who writes anymore? Anybody write stuff?
I'd like to throw people in there.
Ah, thank you. I would too. Good. Instructions, analysis, productivity, people. Yeah. Good. You know, that's actually pretty good. Oftentimes, when I do this exercise, what many people focus on are specific examples of technology itself. So, iPhone, laptop, whatever it might be. Okay? But this is pretty good because you're actually thinking either concepts or tools of the trade or some of these even bigger issues like productivity and people. Good. Very good. Let me share with you my definition of IT. Now, this is concise, succinct. It'd be better if it was longer, and I have a longer one. But this is how I look at IT. Succinctly, information technology is applying and managing the technology used in problem solving. Information technology is applying and managing the technology used in problem solving. Those verbs are chosen rather carefully to convey something, applying and managing. And it would be helpful if I can contrast IT with some other disciplines, like the mother discipline of computer science or other offshoots like information systems. So I'm going to do that. But this is what we focus on in this program. What we're all about is applying and managing technology that's going to be used to solve problems. Now, to understand that better, it's going to be helpful to ask the question, what is computer science? Sorry for all the abbreviations, but CS is just computer science. There's certainly a relationship between computer science and information technology. And the way that I view it is computer science is the mother discipline, and information technology is one of the offshoots of that, among many others. But let's look a little bit about what computer science is so we can see both what's similar, but even more importantly, what's different. Didn't I just ask that question? By the way, sometimes people have a very, let me just put it this way. Computer science is not the detailed study of computers. Sometimes new students come into a computer science program like ours and believe that what we're going to do all day is study the computer. We're going to take computers apart. We're going to put computers together. We're going to take a look at all the specific. That's not computer science. That's not it at all. So what is computer science if it's not the detailed study of computers? This is my definition of computer science. Computer science concerns creating automated solutions to real-world problems using computer systems. Okay. Computer science concerns creating automated solutions to real-world problems using computer systems. Now, what's similar and what's different? Computer science and IT certainly both deal with technology with a focus on computers. Both computer science and information technology focus on problem solving. The difference is the standard operating verbs. IT, apply and manage. Computer science, create. Computer scientists create from scratch problem-solving tools. If this were a degree program in computer science, we'd be spending a lot of time figuring out how to create next-generation distributed operating systems. This is not a degree program in computer science. Now, does that mean we can't talk about operating systems? Oh, we can. But our goal is to apply and manage them. I don't think very many of you, when you graduate, are going to be working for Microsoft creating Windows 15. Okay. I think almost all of you will be working with either a Microsoft operating system or something similar to make sure it actually works in my department, my company, my business, and solves the problem at hand. Okay. Very few of us are going to go to work, in Redmond, Washington for Microsoft Corporation, again, truly working on Windows 15. We're just not going to do that. But someday we're going to be forced to figure out Windows 15, okay? And then make sure that our users have Windows 15 set up, configured, and it does everything that we need it to do. What was the word here? Productively. You bet. Okay. There's even another thing, and there's more too, right? IT is information technology. That's us. Computer science, that's the mother discipline. And there's another one, and there are other ones too, IS, information systems. Now at Concordia, we have a degree program in MIS, Management Information Systems. It's run out of our business school. It's part of our MBA program. And that's really typical. You will find IS programs run out of the business school. Okay. Now, wait, don't IS people deal with technology? They do. So tell me, how does this all work? Let me give you an analogy. Let me first of all give you an illustration, and then I'll work an analogy with you. But I want you to know, too, that, there's overlap, there's differences. I mean, are there IT people working at Microsoft building Windows? Yes. Yes. So we're just talking in general, broad brush strokes here. Whoa, 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 wait, don't, okay, good. Okay, why is this happening first? This is the problem. I redo my slides, I take them apart, put them back together again, and then I don't want to do this way. Well, okay, all right, it's here. Many of my analogies deal with automobiles because I like cars. I fancy myself an amateur race car driver. Okay? I'm not good, but if I had my way, I'd rather be on Road America. Okay? Not today, but certainly on any given night or weekend in the summer. Okay? If you don't know anything about cars or anything about racing, well, I apologize. But I bet you've driven a car before. And even if you've never participated in a race, maybe you've seen it on TV. Okay? You've seen races. You know how it works. When there's an automobile race, the focus is usually on the car and the driver. But if you don't know, there's a gigantic support department for that car and the driver. When Oliver Gavin, he's a race car driver for Team Corvette. When he won the 24-hour de Le Mans, when he won the 24-hour race in Le Mans last year, it wasn't just him, right? There was a gigantic team associated with it helping him. That's kind of like information technology. The race car driver is the user. That's the person we want. We want them to win the race. What we do is we support them. We want to ensure that the user, the driver, has everything she or he needs in order to be effective. You run out of gas, okay? Guess who's going to get yelled at? Is that the driver's fault? No. That's the crew chief's fault. The crew chief, and this again is not a Corvette, it's a Mopar drag racing team. But this individual here is the crew chief, and all those other people work for him. That's what I fancy us. Anybody with a master's degree in IT is kind of like the crew chief. I'm assuming that either now or certainly when you graduate, you're going to have a team of professionals working for you. And your job is to not only coordinate all that technologically, but also ensures that the user can win the race. Well, really, IT is a service activity and a service organization. We win when the user wins. When the race car driver wins, the entire team gets to share in that victory. Yeah, the crew chief and the pit crew, they get to share not only in the victory, but also in the monetary reward that comes with it. It's the same in IT. When we win when our users win. When our users can do their job effectively, when they can do their job better than the competition, then we share in that victory. We support them doing that. That's how I view IT. It's a support organization. Okay, let's use a better example. Sorry, I get away from the analogies. Let's use a more realistic business model and example. So here's the boss. The boss has a problem. Dream up the problem. I hate making these up. Customer resource management. We don't know. Gosh, we've got warehouse full of widgets and nobody's buying them, and they're buying all this stuff, and we do, suppliers and supply chains and all this. It's all out of control. Fix it. Fix it. Now, oftentimes, the first person that hears "fix it" is an IS professional, an information systems person. In this case, she, the IS professional, is well in tune to the enterprise, to the business model. She knows what the business is about. So she hears the boss moaning about customers and suppliers and whatever, and she says, you know what we need? We need a database system to track customer responses, to track trends, or whatever. Okay? Now, an IS professional knows enough to know that a database management system will be the ultimate solution to the problem. Okay? She understands the business, and she also understands technology to the point that she could say, we need CRM. We need a database management system to support CRM. That's how we're going to solve the problem. Now, my IS professional is not technically savvy enough to actually implement the database or to set up the CRM system. To do that, we need to rely on the IT professional. When the IS professional talks to the IT department and says, well, we need a database management system to support distributed CRM. Now it's the job of the IT professional working with the IS professional to say, okay, what are the parameters? Here are some options. Let's choose the the correct database that matches our needs. And now I'm the IT professional. I will apply this to the problem. I will manage this such that it can actually be utilized in our organization. So, Management Information Systems, if you look at the IS program here at CUW, which I helped to create 15 years ago, whatever it is, the focus there is on the enterprise, on the business model, but connecting technology to that. The focus here in the IT program is really on the technology that would help the people solve the problem. We are not going to talk about business models here. We don't, if it's done, and it is done, I shouldn't say it's not, it's done in the database class and the 45 class, but only as it's needed to support understanding of the technology. Our focus is how do we apply and manage the technology to solve this problem. Okay? How do I implement the CRM system? How do I configure it? How do I maintain it? How do I secure it? How do I back it up? How do I train people in its usage? That's my job as an IT professional. Now, what about the computer scientist? Well, her job was to create the database management system that serves as the foundation of the CRM in the first place. A computer scientist, okay? I imagine you've heard of the Oracle Database Management System. If you haven't, then you've heard of other things like Sybase or DB2 or MySQL or similar kinds of things, right? Those products were created by computer scientists. It's a team of computer scientists who created the Oracle DBMS. Now, if you know anything about a database management system, a DBMS does not solve a problem on its own. If you're a user and you go to Oracle and say, I need a database, they say, here you go, $10,000. And you say, thank you. What do you got? You don't have anything that's going to directly solve a problem. What you have is a framework. You have a foundation that now I, as the IT professional, have to figure out, okay, how do I install this on my servers? How do I set it up? How do I create the schema? How do I create the views? How do I secure it? How do I back it up? Exactly, okay? A DBMS doesn't do anything. It's like a spreadsheet. A spreadsheet doesn't do anything. It was computer scientists who created not only the first spreadsheet, kind of stretching the truth, but also, you know, Excel or Wingsy or Pages or whatever it is that you might use. Those are computer scientists. Now, once you have a spreadsheet, is it solving the problem? No. You have to create formulas. You have to create the algorithms. You might want to create a pretty front end for it, you know, the Excel app that runs on top of the spreadsheet. So there's the difference in a nutshell. Computer scientists are creating the foundational package. We as IT professionals will take that and apply and manage it. If you've ever done system administration, your servers are running on a certain system. Maybe they're virtualized using VMware. Maybe you're running Windows Server. Maybe you're running Linux. Doesn't matter. Just licensing Windows Server 2012 and popping it on your box, you're not done. Not by a long shot. Now we've moved from the domain of the computer scientist to the realm of the information technologist, and it's time to get it installed, configured, managed, etc. Big job, right? Huge job, but different. All right. Speaking of the grand ideas, I guess we'll get there at some time. In information technology, I believe there are 9 what I call grand ideas, fundamental concepts that if you understand, you'll be much better at solving problems. Let's look at those. Today, I want to focus on 3 today, and we'll introduce all of them maybe, or maybe at least read them. Let me just give it to you in groups of 3. There are 9. Let's lump them together by 3s. Let me first of all just give you the word, and then we'll come back and give a straightforward definition. First grand idea of IT, algorithms. I bet you've heard this word before. I bet you've dealt with algorithms before. It's a big idea in IT. Second grand idea, abstraction. I'll give you a concise definition of each of these in just a minute. And the third grand idea, automation. Algorithms, abstraction, automation. Now, the actual definition of each of these terms is big, deep, long, complex. But let's start off. We've got to start somewhere. So what's an algorithm? An algorithm is a method of problem solving. An algorithm is a method of solving problems. I know you can't read the caption mainly because it's not only small but also cut off, but you can see a whiteboard full of equations, and the one engineer says to the other, and that, in simple terms, is how you increase your ranking in a search engine. We've all heard of Google's algorithm. How they determine what hit. When you search for whatever term it is, how do they rank all those returns? That's their top secret search algorithm, right? Exactly. It's a method of problem solving. That's what an algorithm is. Now, in your text, in chapter 0, oh, folks, somebody's have to remind me. I got to bring this other book for you. I know I forgot. I was doing something else. But in chapter 0 of Brookshire, Brookshire's a great computer scientist, right? Chapter 0, Introduction to Computer Science. He's going to talk about some of these grand ideas. By the way, he has different terms for them, and he doesn't have as many as I do, but that doesn't matter, right? We'll just deal with these. Figure 0.2, the Euclidean algorithm for finding the greatest common divisor. The greatest common divisor is the largest whole number, the largest integer that evenly divides 2 other values. There's an algorithm to determine that. And this is it. You remember back in the equivalent of high school algebra, and you were doing funny things like this? Yeah, that's an algorithm. We deal with algorithms all the time also. So, you tell me. Tell me some examples of some algorithms that you've come across in IT, either personally or professionally. This is a little esoteric. I haven't given you a concrete example. Okay, I'll give you one example. That news article that we saw earlier. There's an app to tell you the odds of your plane crashing. Okay? That app is built on an algorithm. I'm assuming that it's not using the built-in artificial intelligence of the iPhone, because there isn't any, right? I'm assuming it's not just guessing. I'm assuming that there's an algorithm to determine what are the odds that your plane will crash. Okay? So here's an app, the plane crash odds app. There's an algorithm for that. Ah, that's a no. Google search. There's an algorithm for that. Anybody ever use a word processor? Spell check. There's an algorithm for that. Okay? Can you think of any other algorithms that we come across in IT? either personally or professionally? One way to think about it is any application package that you use, any identifiable feature or function is really built as an algorithm. When you're using a word processor, any feature or function is built as an algorithm. So spell check, when you issue the spell check command, there's an algorithm. It compares your data to a standard dictionary of correctly spelled words, looking for an equality match. If your data, if your word that you typed is in the dictionary, it said must be a word. On the other hand, if in comparing your data, the word you typed, to the dictionary, it cannot find an equality match, it's not in there, then it responds by saying, we believe that this word is misspelled. When you save your document, there's an algorithm that controls that. When you print your document to the printer, there's an algorithm that controls that. Word wrap, the automatic continuation of typing on the next line. You know, if you're old enough to remember typewriters or have seen them in a museum, you know that when you got to the end of the line, you had to go, or an electric one, return. We don't do that. The algorithm determines what to do. Okay? So the answer is, almost any feature or function you can think of any piece of technology is really built on top of an algorithm. Yeah. Now, computer scientists focus on creating algorithms all day long. That's what they do. How do I do spell check? How do I do it better? We are also going to focus on algorithms, but we're not always going to be creating them. Sometimes we do, but more often we're going to be doing other things when it comes to algorithms. We're going to say, hey, this is dumb. Every time somebody in my XYZ company types the name of our company, XYZ, the spell checker says it's misspelled. That is dumb. Can I fix that? If you don't know, you can. You can add that as a word to the spell check library. That'd be a great thing for us. And now, we haven't changed the algorithm. We've changed the data it works with. And now, all our users are happy. Okay? So, computer scientists work with algorithms. Information technologists work with algorithms. It's just sometimes we're looking at them a little differently. All right. Now, you said, wait a minute, you told me, no, I didn't tell you the definition of an algorithm. The definition is horrible. And Brookshire's even worse than mine. Okay? Here's my definition. Brookshire's is even longer. Where's the definition? There it is. An algorithm is an effective, detailed, and unambiguous set of step-by-step procedures for solving a problem. An algorithm, effective, detailed, and unambiguous set of step-by-step procedures for solving a problem. What? We're going to unpack this. I'm not going to do it today. We'll do it, I don't know, third unit or something. Each of those first three terms, each of those adjectives, effective, detailed, and unambiguous, they mean something important. We want to unpack that and see what it is. Now, for now, I'm just going to have you read. You'll read chapter 0 and you'll see what Brookshire says about it, etc. But I want to point out something on page 4. This is what Brookshire says. It is through this ability to capture and convey intelligence by means of algorithms that we are able to build machines that perform useful tasks. There's an enormous amount of stuff in that sentence. The ability to capture and convey intelligence by means of algorithms. That's a real deep sentence. It's absolutely true. It's actually beautifully crafted. There's a lot of stuff there, though, okay? I guess what I'm saying is, when you read through this book, this is not like light reading, okay? Spend some time wrestling with it to make sure you know what is the author saying. Oh, and by the way, J. Glenn Brookshire is Professor Emeritus at Marquette University. Marquette is in downtown Milwaukee. So why don't you just give him a call if you don't understand something? I'm just kidding, okay? He'll be happy that you bought his book, but I just don't think he has the time or inclination to answer every question. But I don't know, give it a shot. Maybe he will. By the way, when you see that abbreviation, that is this book. CSAO is Computer Science, an Overview. I don't write things out. I abbreviate everything. CSAO, Computer Science, an Overview. Near where he talks about algorithms, you're going to see a figure 0.5. I'll show it to you in just a second. But I'm going to ask you to read this during this first week. And I'm going to ask you to think about this question. Which aspects of algorithms are more important to an IT professional as opposed to a CS professional? To answer that question, you're going to have to think, what's different about a computer scientist versus an information technologist? I tried to share some of those differences with you already. Realize Computer Science, an Overview is written for computer scientists. So Brookshire isn't going to tell you the difference. I'm telling you the difference. Now here's that figure. When you look in the text, you'll see figure 0.7. And what Brookshire is saying is algorithms are central to computer science. I'm going to tell you that algorithms are one of the grand ideas of information technology. Doesn't surprise us. IT is a subdiscipline of computer science. But, some of these attributes or characteristics of algorithms are more important for a computer scientist, while others are more important to an information technologist. Let me give you an example. The discovery of algorithms is a primary concern for computer scientists. Think about my definition. Create. Computer science concerns creating automated solutions to real-world problems using computer systems. Computer scientists create algorithms. It's the computer scientists at Google that thought about, hey, how do we rank the results of a search? You wonder how they did that, right? They just Googled it. No, they are Google. They had to create it, right? Right. So, discovery of, in other words, the creation of algorithms is the primary domain of computer scientists. We, as IT professionals, are not as concerned about that. On the other hand, the application of algorithms is a primary concern of IT professionals, less of a concern of computer scientists. The example I shared with you, the database management system. The algorithms that make up the DBMS were discovered and created by the computer scientists at Oracle. After they created it, they just handed it to us. Okay, they want $10,000 for it. But they handed it to us as IT professionals. It doesn't work out of the box, does it? We now have to, where does it go? Here it is. We now have to figure out how to apply it. Right? Think about the definition of IT. The application and management of technology used in problem solving. Okay. One of the homework assignments, and I'll show you them all after a while, but one of the homework assignments for this evening that you'll complete before next time is to answer this question. Of these 7 attributes, which are more important for an IT professional as opposed to a computer science professional? Don't worry, it's written down. Okay, you don't have to memorize it now. But legitimately, you could say, well, sometimes we discover algorithms, and you're right. So you have to think big picture. Think grand ideas here. This is a hard, this is a hard problem. The answer to the problem is not in the text. If you read that carefully from cover to cover, the answer to the question I'm asking you is not here. The solution is, but the answer isn't. This is a classic graduate question. You can Google that question from now until eternity. The answer is not online. You have to think about it. So, how are you going to solve that problem? First of all, you already have a lot of knowledge of IT. So, given your current knowledge base, think about, read what Brookshire says. Be sure you understand. What's he mean by these things? By the way, by communication, he doesn't mean data communication here. He's talking about the communication of algorithms. So read it, make sure you understand. But then apply what we've discussed here. I've given you enough background such that you could figure it out. As a matter of fact, I've already told you one of the answers. Right? There's at least one thing here that's really more important to IT than CS, and that was? Okay, that was? Give me another one. Application. That's the one I told you. Okay? Yeah. Now, your job is to think CS, IT. I'm an IT professional. Which is going to be more important to me? And of course, don't just list. I want you to list them. But then tell me why. I'll show you that problem before we leave today. You don't have the coding text. I will go get that and make sure you have it so you can look at it. During this class, I'm going to ask you to look through several of the chapters. Now, a couple of things I need to say. The coding text is a little old. It has a 2005 copyright. That's 10 years old, and that means this is ancient history in the world of IT. It really is. Why am I using it? Because the publisher, Blue Line Press out of Chicago, was gracious enough to give me a huge discount on a shipping container of these things, okay? At some point in time, we'll update this. But again, it doesn't matter. If this had a 2015 copyright, it'd be out of date also, right? Now, most of the technologies here are still being used. Java, C++, C#, VBNet, Perl, COBOL. Many people smirk with that. More businesses run on COBOL today in 2015 than any other language. It's still used, right? Okay. XML, HTML, VBScript. Now, the problem is it will be older versions. You know, C++, there's a new ANSI standard for it. It's not talked about here. And the chapter on Microsoft Windows, because it is circa 2005, is talking about Windows XP. That is out of support, right? Okay? Maybe kind of, sort of. But believe it or not, more than a third of all Windows shops right now, 2015, more than 33% of all businesses that use Windows are using Windows XP. Nobody uses Windows 8. Nobody. Okay? And it wasn't until nobody used Windows Vista either. It wasn't until 2 years ago that Windows 7 overtook Windows XP as more installed users. Okay? The steam is there, to be sure. Okay? There are more XP users than there are Windows Vista users. And there are more XP users than there are Windows 8 users. So I'm sorry, you might still come across it, but even more importantly are the concepts there. If you're not a Windows user, some of us use Unix. Some of us use the Mac OS. Windows is weird. Well, I'm going to just ask you to read through it because when you're working with our systems on campus, in some sense, we are a Windows shop. I think, yeah. Okay, good. We are going to take a break.